We just learned about capacitance, which is where you have two metal conductors that are connected to some voltage source and can thus collect charge, storing potential energy. We're going to talk about a special type of capacitor today. It's called a dielectric. Now, a dielectric is a capacitor with, a dielectric is an insulator that is often placed in between the plates of a capacitor. So dielectric is the insulator, and we're going to characterize the dielectric constant with the capital letter K, capital K. So you have two plates which in air, having air in between, you have a capacitance of epsilon naught A over D. But if I take this capacitor and I fill it with some material, then epsilon naught is going to be replaced by some epsilon for that particular material, and that epsilon is calculated as K times epsilon naught. So your capacitance is epsilon times, epsilon times area over D, but epsilon is just K times epsilon naught, and so you end up getting this equation here that we have showing on the screen right here. Well, what would be the use of something like this? Well, here's some different dielectric field strengths, and you can see that all of these different materials have much larger dielectric constants than just plain air. Well, if you look at Q equals CV, then let's go ahead and write this out. This is your equation for capacitance, and we multiply that by voltage. But this value here is just the capacitance with air. We're going to call that C naught in this case, so it'll be K times C naught V. When you have a dielectric constant that has a higher value, then the charge also increases rather significantly. For example, let's say that I have a capacitor that has some capacitance here. Let me start this over here. Let's say that I have a capacitor with air that has a capacitance of 5 microfarads. And I put it under an influence of a voltage of 1 volt. Then the amount of charge I can build on it would be CV, which would be 5 microcoulombs, capacitance times voltage. But if I say that I'm using, what's a good one? We'll use oil, just because that's a nice even number. The capacitance with a dielectric of oil is then going to be 4 times my initial, I don't know why it does that. 4 times my initial capacitance. So now I have a capacitance of 20 microfarads under an influence of 1 volt. The amount of charge that would build up would just be capacitance is 20 times 1 volt, 20 microcoulombs. So all of a sudden, I have changed the amount of charge that I can build up on my inside my capacitor. Now, molecules in a dielectric do tend to become oriented in a way that reduces the external fields. However, because of that, it allows for more charge to be built up. So you have your capacitor with air, is shown here in figure A, And then figure B, you introduce a dielectric. Remember, an insulator, you do not, charges will not actually move to other sides, but they will start to be polarized. Positive charges will be pushed towards the negative plate, negative charges towards the positive plate. And as a result, you do tend to have more of a negative charge over here, which is going to attract more positive charges, allow the positive charges to build up a little bit more. I need to correct myself. I said negative charges build up on the left side of the dielectric. No, negative charges don't build up. The dielectric's just more polarized, so it tends to be more negatively charged on the left side because of the separation in these different molecules. Likewise, the right side will tend to be slightly more positively charged, thus attracting more negative charges in the negative plate, and so you can end up building charge much higher. And bottom line, when you have a dielectric, the electric field within the dielectric is less than it would be in the air, which allows more charge to be stored for the same potential. So your two capacitors here, one with air and then one with some material in the middle. You can have everything exactly the same. Same voltage, same initial capacitance, but then that would change the capacitance here because of the dielectric, and just that one little thing changes the amount of charge that you can build up on the capacitors.